Next.js has a new image component that's promising to help my site lose some weight. So let's take a look and see if we can lean out some of these images together. So we're looking at the home page of my site right now, and if you reload it, you'll see that we load these 4 images and they total 7.3 megabytes. So we've got this one right here of me, and then if we scroll down, we'll see that we have a New York, Burlington, and Boston image. 7 megs is pretty hefty. So let's come over here to my homepage image, and you'll see that right now I'm just rendering this little image component, which if we pop it open is a component that I wrote in this project. We'll see that it renders an image tag with just the normal source attribute, and then we also use this little CSS trick to wrap it in a div with padding bottom equal to the aspect ratio. And this is a nice trick because let's say this image were to take a long time. If we reload the app with that image blocked, we'll see that none of the content shifts. That image component holds the place for the image until it loads, so you don't see any flash of unstyled content. So that's what this div is about, and then right here we actually render the image. And we're gonna see that Next's new image component does exactly the same thing for us. So the first step is we're just gonna replace this with the image component, which we're gonna come up and import image from Next image. And then we're gonna see this helpful error message from Next that says we must provide a width and a height. So instead of this aspect ratio prop, we're actually just gonna pass in a width and a height. The width of this image is 1616 and the height is 1080. And that's all there is to it. Now we'll see that sam.jpg here is a JPEG image and is 327 kilobytes. Let's go ahead and save this and refresh our app. And now we're gonna see this new image right here. It's making a request to _next/image. This is the homepage hero right here, and it's come down to 24 kilobytes. And we'll also see that it is a type of WebP, which is a new image format that is optimized for the web. So right off the bat here, we have saved some weight just because Next image is actually making different versions of this image using this new format. But even more than that, if we were to take a look at this image tag in our HTML, we'll see that Next is rendering this cool source set attribute, which specifies all these different versions of the image at different sizes. So when we're on a screen that's only 375 pixels, we get this 24 kilobyte version. But if we were to jump up to, let's say, a laptop, we actually see a new request, and this one is 47 kilobytes. And if we look at the URL, we'll see that the width in the query param here has jumped up. And this is how Next image is doing its magic. Basically, this source set attribute gives all these different versions of the images at different widths and qualities, and it lets the browser determine which one to request based on the width of the device. So this is pretty awesome, and already we've cut down a little bit on the size of our images. But we can see that we still have about 7 megs of images here because these other 3 images are really what's costing us all this extra size. So let's go ahead and fix those too. Now all these are being rendered from this image card component, which under the hood is using my old IMG component. We'll just replace this with Next image. And again, we want to get rid of this aspect ratio, give it a width and a height, which we can just pass in as props. Width and height. So now if we come back to where we're using image card, we'll start with New York. This has a width of 5567 and a height of 3132. Burlington has a width of 2448 and a height of 2448. And Boston has a width and a height of 3456. So let's save that, come back over to our app, give it a reload. And now check this out. We're only loading the first image, so we only have loaded 24 kilobytes of images so far. Now you might be wondering what happened to the other images. Let's go ahead and scroll down. There we see them, and they just popped into the network inspector. Now these are all WebP, and we can see the size has drastically cut down. So all 4 of our images have went from over 7 megs down to 194 kilobytes. And the reason that they only loaded once we scrolled within them is because built into this image component is an observer that checks how close we are to the images, and it waits until we're within a certain scroll distance from them before loading them. So you'll see here again, if we just look, we see only one image loaded, but as I scroll, once I get within a certain threshold of those images, we saw them pop in right there. So by the time we come down here, we can see all of them are loaded. So all of this is pretty amazing. It's really the kind of thing you would expect to be built into the browser, but now with this great new image component, we get it for free. And again, if we were to go ahead and raise this screen back up to 1024, we're gonna get nice big versions of these images. They're gonna look great, but they're still gonna be much smaller than the originals were. We're still down to 100 kilobytes, 50 kilobytes, and 200 here. So if we were to reload this again and check out the entire 4 images, all on a 1024 screen, we're still going to be way under half a meg here. So this new component really does what it was advertised to do, and we basically didn't have to do anything. We didn't have to write any of these source sets, but we can see a lot of work going on behind the scenes here. The browser is able to do what it wants. If you're on a Retina device, it will request the right version. A non-Retina device, a bigger or smaller device. Basically, the browser and Next are taking care of all this little nitty-gritty work, so we can just get much faster images and much smaller payload sizes. And one really cool thing about this is because I deploy my personal site onto Vercel, all this is just going to work out of the box. I don't have to upload my images to a service like Cloudinary or ImageX. Vercel is basically going to generate the different versions of these images lazily as they're requested using its backend, and then it's going to cache all those images for me on a CDN. So all of this happens lazily, so it doesn't slow down my builds when I run yarn dev with this new image component. Even if I had a ton of images in my project or a ton of images hosted on a service provider somewhere that I was loading with this component, it wouldn't slow down my dev because all this happens lazily and the caching works just great. So again, this is really impressive, and all you got to do is be on Next 10 and load this bad boy right from Next Image. And with that, my work here is done.